Yes, image formation by refraction and image formation by refraction. The second case is first case we did when object is in denser medium and observer is in rarer medium. It will be this is the case that we did last class, and I gave you to solve 2-3 questions. In the numerical section, there are only 2-3 questions from the exercise. I hope you would have done that. Jayesh,
Yes, sir.
completed the exercise?
No, sir. Sorry.
Only 2 questions were there. Okay, Mr. Auguste, what was the condition here? Under what condition we can apply that? Under what condition we can apply that the apparent depth is 1 by mu times real depth? Because the condition was that we are looking close to the normal, or we are almost perpendicular to the surface. For an oblique view, that formula will not be correct. And we did the derivation also, that y apparent depth of this fish appears to be 1 by mu times the actual depth. Similarly, the bottom of any container filled with liquid seem to be slightly shifted, and that is shift is also called as normal shift. That shift is d minus d by mu. This is the shift in the position of fish or any object which is now put in a denser medium. When it was in the air, it was at a depth of d. This is the case that we did last class. Ray diagram was that the light ray starting from the object will be slightly deviated away from the normal, which will make the image above the actual position. Second position is when the observer is in denser medium. The second case we didn't do last class, when observer is in denser medium. So for practical case, we can see that fish is maybe the observer now, or a person has dived inside the water and now he is trying to see anything outside of the water. तो अब बाहर फिश तो नहीं होगी, हम एक बर्ड कंसीडर कर लेते हैं. Suppose there is a bird. Assume करें ना, this is a bird. Yes. And a fish is trying to see this bird. So अभी observer कौन है? Fish. The observer is this fish, and he is trying to see upwards. Light should always start from the object. So it should start from the bird. Now light is going from rarer to denser medium because it is air, and water is that denser medium, and denser medium refractive index is mu. As a result, the light ray will be slightly bent. Fish is the observer, so fish को जो ये light ray लगेगी कहाँ से आ रही है? One light ray we can assume that perpendicular one. So it will be when we extend these two, it seems to be forming a virtual image above the actual position of the bird. Actual position of bird is O, which is the object position, and now the fish will be observing the bird at position I, which is nothing but virtual image. If the real height is h, the apparent height of this image will be h dash or h apparent. So the apparent height of this position of the bird will be mu times h by the same logics. Mu sin I is equal to sin r. So if you want to get this derivation again, we'll not do it because it is exactly same method. Ye I, so here it will become I. This angle is R, here it become R. So we can write 1 into sin I is equal to mu times sin R. और फिर हमने जो derivation में use किया था logic that these points are very close. Suppose P and M are very close. So we can take OM is equal to OP and IM is equal to IP. Apparent height where h is the actual height of the object from the surface. बट जब वाटर के अंदर जाते हैं तो हम बहुत सारा कुछ देख नहीं पाते बाहर की तरफ, है ना. अगर प्रैक्टिकली आपने ये फील किया हो, go inside the pool and dive in and try to look outside, we won't be able to see much. उसका एक और रीजन है which we'll be doing today called as total internal reflection. क्योंकि लाइट अंदर से बाहर ज्यादा आ नहीं पाती है. That doesn't come out much. Only a very small portion of light will be coming out. In this case and last case, you got the difference. पिछले वाले केस में क्या था? The observer is in air और object था denser medium में यानी पानी के अंदर. In this situation, the object is in denser in rarer medium and the observer is in denser medium. So the image position or the formula will depend upon the position of the observer, where the observer is. So अगर हम एक combined question ले लेते हैं, बिना इसमें कोई डाउट, ये डेरिवेशन मैंने किया नहीं, बट अगर हम इसको दोबारा करेंगे तो क्या होगा? 1 sin I is perpendicular PM divided by hypotenuse which is OM is equal to mu. Sin R is again perpendicular divided by hypotenuse IM, and since point M and P are very close, so हम IM को लिख सकते हैं IP और OM को approximately लिख सकते हैं OP because P and M are very close or have to be very close for the perpendicular view. हम इन ऑब्जेक्ट को perpendicularly देखेंगे, only then these formulas will be applicable. PM gone. OM IM becomes IP is equal to mu times OP. IP is that H dash or H apparent. Apparent height of the bird position that will be observed by the fish is mu times the actual height. H apparent will be mu times real height. Yes. So अगर हम एक कॉमन सा क्वेश्चन लेते हैं, सपोज एक फिश है और एक बर्ड है. This is a fish. Let's say it is 32 centimeter below the surface, and there is a bird 60 centimeter above the surface. The refractive index of the water is 4/3. ऊपर का मीडियम एयर है, नीचे का मीडियम है वाटर. Now the question is, find the distance of fish that appears to bird. First part, find the distance of fish that appears to bird. Second is find the distance of bird that appears to fish. पहले वाले में ऑब्जर्वर कौन है? जयेश, who is observer in the first case?
In the first case, it will be the fish. That's the observer.
फिश की डिस्टेंस ऑब्जर्व कर रहा है और कौन कर रहा है?
क्या sir?
Who is observing that distance? Bird. फिश की डिस्टेंस को कैलकुलेट कर रहा है या मेजर कर रहा है और कौन कर रहा है? बर्ड. सो बर्ड इज द ऑब्जर्वर. पहले केस में बर्ड इज ऑब्जर्वर और वो कौन से मीडियम में? बर्ड इज ऑब्जर्वर एंड इट इज इन रेयरर मीडियम. ये पहला वाला केस हो गया. बर्ड फिश की तरफ देख रही है तो बर्ड इज ऑब्जर्वर. कितने डिस्टेंस पे दिखेगा? What will be the distance that appears? So 60 तो 60 रहेगा. अपने मीडियम में तो कोई चेंज है नहीं. जो फिश की पोजीशन थी वो अपने पोजीशन से 1/μ हो जाएगी. So 60 will remain 60 only, but 32 will appear as 32/μ. This is the distance at which the bird will observe the fish from itself. Right? यस बेटा, सर पे कॉल आ गया था. हाँ, ये समझ में आ गया. पहला वाला केस 60 तो 60 रहेगा क्योंकि तो अपने मीडियम में कोई चेंज हो नहीं रहा. देयर इज नो चेंज इन मीडियम, नो रिफ्रैक्शन. बर्ड को सरफेस 60 सेंटीमीटर पे दिख रहा है और जब फिश की डेप्थ है 32, दैट विल बिकम 32/μ. तो 32 डिवाइडेड बाय 4/3 कितना आ गया ये? विहान
Yes,
Vihan,
sir.
you understood this question?
Yes, sir.
60 में कोई चेंज नहीं होगा क्योंकि वो तो उसी मीडियम में है. When it goes into the other medium, like we observe in the denser medium, then the depth will become 1 upon mu times. Likewise, when fish is the observer and it looks toward the bird, bird की जो actual height है वो h है, but the height that will appear to fish will become mu times more. So it will become mu times h from that medium.
सर ये 4/3 क्या है?
बेटा रिफ्रैक्टिव इंडेक्स है ये. वाटर का रिफ्रैक्टिव इंडेक्स इधर लिखा हुआ ब्रैकेट में, रिफ्रैक्टिव इंडेक्स ऑफ वाटर. यूजली ये 4/3 ही होता है फॉर द प्योर वाटर. इट इज गिवन इन द क्वेश्चन. गॉट इट?
Yes, sir, got it.
जब हम एक मीडियम से दूसरे मीडियम में देखते हैं, देन फॉर्मूला विल बी divided by mu or multiplied by mu. It will depend upon who is the observer. So in the first case, bird is observer, bird is in rarer medium or denser medium में देखने पे it will become 1 by mu times. In the second scenario, fish is the observer and it is looking the bird. So जब हम denser से rarer की तरफ देखते हैं तो जितनी distance अपने medium में है, fish के लिए surface तो 32 पर ही होगा, और जो बाहर का medium है, the height of bird, that is 60, will appear 60 times mu. Right? क्योंकि डेंसर से रेयर में देखने पे ऑब्जेक्ट की हाइट बढ़ जाती है. फ्रॉम h it becomes mu times h, and when it looks toward denser medium, then height will be less, so that will become 1 by mu times h. ठीक है, ये सेकंड वाली कैलकुलेशन. कबीर, what is the height of bird that appears to fish? Mr. Kabir? Yes, Kabir, what's the answer for second part? What is the distance of bird that appears to fish? Kabir? कोई बात नहीं. Tejas, what's the answer for this second part? What is the, I have just given you the formula, you need to put the value and solve.
So the 32 plus 60
How much?
divided by 4/3.
इसको सॉल्व करके बताओ कितना आएगा. ये तो मैंने कर ही दिया है. 32 तो फिश अपने वाटर का सरफेस,
Yes, sir.
it will remain 32 only. So on solving it become how much? 112.
Yes, sir.
Yes, it will be 112 centimeters. So from the fish, the bird will appear at a distance of 112 centimeters. Very nice. So I think we did this image formation by refraction, and exercise में कुछ 2-3 क्वेश्चन ही थे. एक्सरसाइज
सर मुझे एक चीज नहीं समझ आई इसमें.
बोलो.
सर why is हम फर्स्ट वाले में why are we dividing by the refractive index and second वाले में why are we multiplying by it?
Very good. I have categorized this into two different parts. अब डिवाइड करेंगे जब ऑब्जर्वर जो देख रहा है वो रेयर मीडियम है. जैसे यहाँ पर this person is the observer. So when you are in air and you are looking for the bird, for the fish which is underwater, observer is in rarer medium and object is in denser medium. Rarer से denser में देखने पर ऑब्जेक्ट की डेप्थ 1/μ टाइम्स हो जाती है, विच मीन्स अपैरेंट डेप्थ कम हो जाती है। सो यहाँ पे जो पहली सिचुएशन थी उसमें ऑब्जर्व कौन कर रहा है, ये क्वेश्चन मैंने आपसे पूछा था, वो हु इज द ऑब्जर्वर? बर्ड। बर्ड नीचे फिश की तरफ दिख रही है, तो उसको कितने डिस्टेंस पे फिश दिखाई पड़ेगी? सो व्हेन ऑब्जर्वर इज इन रेयर मीडियम और वो डेंसर में दिखता है, तो ऑब्जेक्ट की डेप्थ 1/μ हो जाती है। जयेश,
यस सर,
understood? The
सर
first
समझ आ गया।
the first question is related to the first part. सेकेंड वाले केस में क्या है? When fish is the observer, so जब denser medium के अंदर से कोई देखता है, जैसे ये fish दिख रही है, या suppose a person has dived into water and then he is trying to see something outside of water. अभी observer is this person who has dived into inside and is trying to see anything from outside world. इसके लिए जो भी ऑब्जेक्ट h हाइट पर एक्चुअल में है, उसकी हाइट h से ज्यादा अपीयर होगी, बिकॉज द लाइट आफ्टर रिफ्रैक्शन सीम टू बी कमिंग फ्रॉम अ पॉइंट अबव द एक्चुअल पोजीशन। ऑब्जेक्ट O, इमेज I, this is h and here it is h dash. राइट? सो सेकंड वाले केस में फिश को बर्ड देखना है, मतलब फिश इज ऑब्जर्विंग द बर्ड। सो जब फिश ऑब्जर्वर हो जाएगा, ऑब्जर्वर इज इन डेंसर मीडियम, तो बाहर वाली चीज जो एक्चुअल हाइट h पे थी वो म्यू टाइम ज्यादा हो जाएगी, उसके लिए बर्ड की हाइट 60 टाइम्स म्यू हो जाएगा व्हेन द बर्ड इज लुकिंग फिश इज लुकिंग टुवर्ड्स बर्ड।
फैमिली आ रही है।
हाँ बेटा।
सर सॉरी, कोई रूम में आ गया था, एक्सीडेंटली अनम्यूट कर लिया।
अच्छा कोई बात नहीं, ठीक है। अंडरस्टूड ना? यू आस्क्ड द डाउट व्हेन वी डिवाइड बाय म्यू एंड व्हेन वी मल्टीप्लाई बाय म्यू। क्लियर? Some consequences of the refraction of light, some practical observation where we observe the refraction and due to which, so we'll just try to discuss it practically. Book में लिखा ही हुआ है, some practical observation of refraction of light. Mr. Kabir,
Yes, sir.
Kabir, why do stars twinkle? Twinkle, twinkle, little star.
सर कैन आई
What is
आंसर?
it? नहीं, I asked Kabir.
सर अगर वो नहीं बोल पाते तब मैं बोल दूंगा।
अरे थमो, why are you so excited? You will get.
सर क्योंकि ये ऐसी कुछ चीजें में से है जिनका आंसर मुझे पता है।
Because of lights, sir.
Kabir, speak little louder.
Sir, because of when the light bends, so that's why.
So light bends and it will not twinkle. Here, this bird will not start twinkling. And you just see why there is
Refraction
twinkling of
effect.
star.
सर एटमॉस्फेयर में बहुत अलग अलग लेयर्स हैं और उन सबकी डेंसिटी अलग है। तो जब लाइट रे स्काई में से नीचे आ रही होती है, हम देख रहे होते हैं ऊपर, तो द रे ऑफ लाइट वो बार बार बेंड होती है, नॉट वंस, बहुत बार बेंड होती है, जिसकी वजह से वो ट्विंकलिंग इफेक्ट आता है।
बहुत बार बेंड होती है तो ट्विंकलिंग इफेक्ट आ जाएगा। ओके,
Yes.
व्हाई बहुत बार बेंड होने से ट्विंकलिंग इफेक्ट क्यों आएगा? मतलब हमें तो वो फाइनल वाली लाइट दिखाई पड़ेगी ना जो हमारे पास आ रही है। सपोज ओके, आई जस्ट एक्सप्लेन व्हाट आई एम आस्किंग। ये स्टार है, स्टार से लाइट आ रही है, ऊपर की तरफ रेयर होते हैं, नीचे की तरफ डेंसर होते हैं, ऐसा अज्यूम कर सकते हैं। सो इट इज स्लाइटली बेंडिंग, बेंडिंग, और मे बी समटाइम्स बाय चांस इट्स गोइंग अवे। सो यहाँ पे जो पर्सन है उसके आईज में जो फाइनल वाली रे आ रही है, उसकी वजह से एक इमेज It has nothing to do what happened in between, how many refraction are there. For him, that doesn't matter. इस person को जो image दिख रही होगी वो star की image है, which is independent of how many refraction it has taken place in between. Your answer is correct, but not complete. I mean, it's not explaining the exact phenomena of twinkling. Yes, there are multiple refraction, that is true. But how does that multiple refraction gives the twinkling effect to the star? That I want. Riddhi, can you explain? Riddhi? Riddhi, you understood the question? Riddhi, okay. What happened?
So I think ये point भी हो सकता है कि वो atmosphere की जो layers हैं they keep on moving. Like the
Okay,
air.
Google come into play. Very good. Very nice.
Sir, optical tensor.
हाँ, that is the point कि जो ये image बन रही है वो एक position पे fix नहीं होगी because of the wind and because of the other factor. These packets are not fixed. These layers are not fixed. They keep on changing. उसकी वजह से ये image एक position पे नहीं बनती है. That image will be formed at some different position. As a result, when it comes slightly closer, it will appear denser. When it will be slightly far, then it will be appearing little faint.
लेकिन सर विंड जैसे स्मॉल फोर्सेस लाइट को थोड़ी ना अफेक्ट करते हैं.
लाइट को नहीं, एयर को तो इफेक्ट करेगा ना. एयर की जो डेंसिटी है, एयर की लेयर, ये कोई बाउंड्री नहीं ना. हवा चलेगी तो ये ऊपर वाला डेंसर हो जाएगा, नीचे वाला थोड़ा सा मिक्स. दिस बाउंड्री कम्स हियर एंड दिस बाउंड्री कम्स हियर. कोई ऐसी नहीं ना कि आप 1 मीटर तक जाओगे तो एक तरह की एयर है, उसके साथ और ऊपर जाओगे तो दूसरी तरह की एयर मिलेगी. इट इज नॉट सेम.
ओके सर.
You understood the point, na?
यस सर.
So it is not just the atmospheric refraction, it is the change in the position of atmospheric layer which causes the shift in the position of image, and that gives us the twinkling effect of stars. So you can write it because book में एक line में लिखे खत्म होता है, उसमें थोड़ा अच्छे से explain नहीं है. Okay, Riddhi, I think you got locked out or something. I asked a question, why the stars twinkle? So this light ray coming from stars suffers multiple refraction, that's true, but how does it give the twinkling effect? Because these are the air layers. The layers of air will be moving due to wind. Layers of air will not be a fixed layer, it will be moving because of the wind and other effect, due to which the position of star will be slightly, the image of star will be slightly changing its position. When it is slightly closer, it appears little bright, and when it is farther, it will be slightly faint, right? So a star appears twinkling due to change in position of image formed by multiple refraction through the layers of air as the layers move due to wind and temperature effect. हवा से भी और टेम्परेचर से भी इनकी पोजीशंस चेंज होती रहती है. So that shift in or change in the position of image gives the twinkling effect. Right? Okay, that's the first observation, practical observation where refraction comes into play. Refraction का रोल सिर्फ इमेज फॉर्मेशन में, रिफ्रैक्शन की वजह से ट्विंकलिंग हो रही है? नो, रिफ्रैक्शन की वजह से हमें इमेज दिखाई पड़ रही है. इट्स नॉट द एक्चुअल स्टार दैट वी आर लुकिंग एट, वी आर लुकिंग एट द इमेज ऑफ द स्टार, but the position of the image will change because the position of the layer will also be changing. Second observation, the sun rises little before the actual sunrise, I mean at least 2 minutes before, and similarly in the evening. So it is early sunrise and delayed sunset. हमें horizon के ऊपर आने से पहले ही sun दिखने लग जाता है, and similarly horizon से थोड़ा सा नीचे जाने पर भी we will be at least for the 2 minutes more we observe the sun. What is the cause of it? Yes. Anyone? Suresh, what is the cause of early sunrise and delayed sunset?
Sir, it's because due to the slowing down of light in our atmosphere, the time it takes for the sun to reach is increased.
If the speed becomes slow, then how the time begin? How does it increase then?
I'm sorry, I think due
What it is asking is the property is that before the sun actually comes in our field of view, before that we are able to see it. So suppose ये जो ऊपर dotted है, that is the atmosphere. Beyond this is vacuum, Earth, and this is the atmosphere layer. अब जो भी person Earth पे खड़ा हुआ है यहाँ पे, let's say this is the observer, उसको तो sun तभी दिखेगा when sun is above this horizon. But the light ray coming from sun, it is entering into the atmosphere, so it is going from rarer to denser. It will bend towards the normal. Since it bend towards the normal, that will form image. अभी actual sun तो horizon से नीचे है, मतलब it's not in our field of view. This is the actual sun. और जो हम देख रहे हैं वो उसकी virtual image देख रहे हैं because of the refraction caused at the atmosphere layer. When light enters into the earth atmosphere, it is going from vacuum to air, so it is going from rarer to denser. This light ray will bend, and those bent light ray seems to be coming from, will form an image. So अभी actual sun तो ऊपर rise होने में time लगेगा, but before that we start seeing its virtual image. Right? Vihan? Mr. Vyan,
Yes, sir.
होना connected. क्या समझ में आ गया कैसे होता है ये sunrise, early sunrise?
Yes, sir. समझ आ गया.
Is it actual sunrise? No, it's not the actual
No.
sunrise. It is the
हम
image of the sun that appears before the actual sun come above the horizon. The
सर ऐसे तो
person
सर
who is
सनसेट भी 2 मिनट बाद करता है ना, बट हमारे लिए पहले हो जाता है बस.
मतलब sun नीचे जा चुका है but हमें उसकी image दिखती रहती है. Same reason. This is east. Suppose in west, it has already gone below, but the light ray that is coming from sun still form an image. So the second one is the west direction. This is suppose west. Sun has set, but still its virtual image will be observed even for some more time. That's 2 minutes more. सनराइज के टाइम एक्चुअल सन होराइजन से ऊपर आने के पहले ही हमें दिखने लग जाती है उसकी इमेज, और सनसेट के टाइम पे व्हेन सन गोज बिलो, even then the image is obtained before the right. Yes. Understood? बेटा
Yes.
ये
Yes, sir.
सर इसका मतलब वेस्ट में वर्चुअल इमेज बनती है.
हमेशा वर्चुअल इमेज होगी रिफ्रैक्शन के बाद. अब ये बर्ड जो है, जैसे ये तो असली बर्ड तो नीचे ही है ना, ऊपर तो हमें उसकी वर्चुअल इमेज दिख रही है क्योंकि लाइट तो वहां गई नहीं. लाइट कहाँ पे जा रही है? लाइट आपके आईज में जा रही है, एंड दोस प्रोड्यूस द illusion that sun is present, sorry, bird is present above. Virtual image is kind of illusion.
यस.
Yes, boss. बस यही वहां पे हो रहा है. Exactly same scenario is there. So we can write that sun is observed or seen 2 minutes, few minutes, yes, exactly, or tentatively around 2 minutes, 2 minutes before the actual sunrise. Before the actual sunrise. And 2 minutes later, 2 minutes later than the actual sunset, as the image of, sorry, virtual image of sun. Virtual image of sun is formed due to refraction of light when it enters into the Earth's atmosphere. When it enters into Earth's atmosphere. बुक में जो एक लाइन लिखी ना उससे समझ में नहीं आता है क्लियरली, तो दैट्स व्हाई इट्स वेरी इंपॉर्टेंट दैट यू अंडरस्टैंड what exactly is the reason for change, right? Okay. Next, next observation is a coin kept in a vessel not visible when seen from just below the edge can be viewed from the same position when water is poured. I'm just reading the observations that are given in your book. The third observation is that at an empty vessel, suppose there is a coin at the bottom. When you are seeing from edge, This is an empty container. There is no water. When you are seeing the from the edge, coin is not visible. This coin is not visible from the edge in the empty glass or in the empty container. If we pour the water, फिर क्या होगा? If suppose we pour water or any other liquid,
Then the
because of
light
that,
will bend towards the normal and we will be able to see the coin.
light will not bend towards the normal. Light will actually go away from the normal क्योंकि हमें light से हमेशा object से. So पहले केवल जो light इस corner से O से आ रही थी, only that light will be coming to his eye. Now the light rays which is coming through the coin, when it goes, light should always start from object. Now the light which is coming from this coin also enters into the person's eye because the light ray will suffer a refraction. So Jayesh, you understood the ray diagram and clear cut understanding is required. हमेशा image formation के लिए light कहाँ से आनी चाहिए? Object की तरफ से. Light should always start from the object. पहले coin से जो भी light ray आ रही है वो इस person की eye में नहीं पहुंच पा रही. Now the light ray starting from this coin also is able to reach the person's eye. So if water is or any other liquid, denser liquid, if water is poured in vessel, the coin is observed or coin can be observed from the edge. Okay, next is a print appears to be raised when we see through a glass paper or glass slab. That we had done an exact question last class. There's a cross mark. When we put a paper weight, that cross mark seems to be shifted, and that is because of again the refraction. A piece of paper stuck at the bottom of glass appears to be raised. That's the same thing. A tank appears shallow than its actual depth. Or same happens in the pool also. Swimming pool appears very shallow. A tank appears shallow than its actual depth. Tank or swimming pool. Sixth is a person's leg appears to be short when standing underwater. Not just person's leg, कोई भी object. A person's leg appear to be shorter than in all these cases it is because of the refraction produced at the surface. Fine. So these are the practical observations and we did a numerical also. Next concept is the total internal reflection. Total internal reflection is a phenomena again observed in nature, and total internal reflection, as the name suggests, the light will be totally reflected back into the same medium from where it started. How and why it happens? Let's see. So the same case, there is a object, maybe a point luminous object, suppose, is present in a denser medium. एक ऑब्जेक्ट है O which is in a denser medium and बाहर का medium है rarer. Light when it goes from denser to rarer, it bends away. The one which is perpendicular goes undeviated, slightly inclined, angle I is less, angle R will also be less, but sin I by sin R is constant. As the angle of incidence increases, angle of refraction will also increase because sin I by sin R is going to be constant. There will be a particular angle for which the angle of refraction will increase. क्योंकि R भी बढ़ता जा रहा है and it will become exactly 90 degree. The angle of incidence from denser to rarer, at which angle of refraction become 90 degree, that angle is called critical angle for that pair of media. तो पहले दिन डालो ना critical angle. Critical angle is that angle of incidence when light is going from denser to rarer. It is represented as IC or C. The angle of incidence from denser to rarer medium at which the light emerges parallel to the boundary, or the angle of refraction is 90 degree. Right. Understood this situation?
एंड वो 90 डिग्री होने के लिए एंगल को तो दूसरे मीडियम की डेंसिटी बहुत कम होनी चाहिए, है ना, राइट?
ऐसा कुछ नहीं है. Sin I by sin R is constant. I0 तो R0 जो पहली लाइट थी जो नॉर्मल की तरफ आ रही है उसमें I भी 0 है, R भी 0 है. Sin 0 by 0. But when I increases, sin I increases, sin R should increase. So sin I by sin R की वैल्यू हमेशा कांस्टेंट है. I बढ़ रहा है तो R बढ़ रहा है. R की वैल्यू थोड़ी ज्यादा होगी क्योंकि यहाँ पे लाइट जा रही है डेंसर से रेयर में. So in this case अगर हम sin I by sin R करेंगे, that comes out 1 by mu. That comes out 1 by.
मतलब सर जैसे जैसे हम आई बढ़ाते जाएंगे वैसे वैसे आर बढ़ता जाएगा, और जब वो आर 90 डिग्री हो जाता है तब
उस एंगल ऑफ इंसिडेंस को हम बोलते हैं क्रिटिकल एंगल. करेक्ट. यस. If angle of incidence is gradually increased, the angle of refraction also increases, right? And the angle of incidence at which the angle of refraction is 90 degree means light emerges parallel to the boundary. That angle is called critical angle. When light ray goes from denser to rarer, the angle of incidence at which angle of refraction is 90 degree, at which angle of refraction is 90 degree, or light ray emerges parallel to the boundary. Light ray emerges parallel to the boundary of surface is called critical angle. called critical angle.
So is it necessary for the angle of incidence to be in the denser medium?
Yes, only then R will be greater. I से R बड़ा तभी होगा ना जब वो denser से rarer में जा रहा हो.
Yes.
The maximum value possible is 90 degree. It is only possible, the critical angle or this phenomena of total internal reflection is possible only and only when it is going from denser to rarer medium.
So when we increase, okay, nothing.
Yes, yes. When we increase I, R increases. वो मैंने लिखा नहीं है क्योंकि वो तो common sense है. Sin I by sin R increases. So this angle of incidence पे light parallel निकलती है. Parallel निकलने को grazing emergence भी बोलते हैं. In some book you will find this language that light grazes the surface. Graze का मतलब होता है कुछ चीरते हुए something, जैसे bullet graze करती है. Likewise this, when the light ray is incident at such an angle that emergent ray grazes the surface. So इसके लिए अगर हम फॉर्मूला अप्लाई करें, mu is the refractive index of the denser medium, air का 1 है. Apply Snell's law for this particular refraction. Snell's law होता है sin I by sin R is equal to refractive index of the medium in which light goes divided by refractive index of medium to which light comes. So here R is 90 degree. Angle of incidence is IC and angle of reflection is 90 degree. Done. Sin 90 is 1, so यहाँ से आ जाएगा sin of critical angle is 1 upon mu, या फिर हम इसे को sin C लिख लेते हैं. Sin C is 1 upon mu where IC और C is critical angle. अब critical angle किसी एक medium के लिए नहीं है. This is the critical angle for this pair of media. जैसे यहाँ पे water से air के लिए is critical angle for pair of media. Water से glass में different होगी. Water to air it will be different. It depends upon the medium also where it is going. Okay, critical angle is sin inverse 1 by mu. Sin inverse 1 by mu लिख सकते हैं critical angle की वैल्यू, यानी जिस मीडियम का रिफ्रैक्टिव इंडेक्स ज्यादा होगा उसके लिए critical angle की वैल्यू कम होगी. Critical angle for any pair of medium is sin inverse 1 by mu. राइट. अब क्या हुआ, ये क्रिटिकल एंगल एक तो समझ लिया हमने. क्रिटिकल एंगल से कम थी अगर, इफ एंगल ऑफ इंसिडेंस इज लेस तो लाइट बाहर निकल के आ जाएगी. I is less than IC. Now suppose if a light ray goes greater than critical angle. If a light ray is incident at an angle greater than critical angle, ये 90 से भी ज़्यादा हो जाएगा means it will not go into that medium, it will come back into the same, and that will be called as total internal reflection when the light is incident at an angle greater than critical angle. Critical angle से कम है तो वो light बाहर निकल जाएगी रेडियल मीडियम में, critical angle पर है तो वो दोनों मीडियम के पैरेलल निकलेगी along the surface. If it is greater than critical angle, then light will be reflected back into the same medium. No light will go in air. And therefore it is called as total internal reflection. So here, greater the refractive index of a medium, smaller will be the critical angle for that medium. Yes, but इसमें यहाँ तक कोई doubt हो तो बताइए. Anything not clear? Got it? श्रेय, अभी हमने सिर्फ क्रिटिकल एंगल समझा है. जब लाइट डेंसर से रेयर में जाती है तो there are three possibilities. Angle of incidence less than critical angle तो लाइट बाहर निकल आएगी. Angle of incidence is equal to critical angle, लाइट पैरेलल निकलेगी. But if angle of incidence is greater than critical angle तो लाइट दूसरे मीडियम में रह जाके अपने ही मीडियम में वापस आ जाएगी, and then it looks like reflection. There's no reflection. Now it looks like reflection, and therefore it is called total internal reflection. The total internal reflection की दो condition आ गई. Under these two condition, there will be TIR. Short form is from TIR बोलते हैं. जब light denser से rarer में जा रही हो, when light is going from denser to rarer and angle of incidence is greater than critical angle, and angle of incidence is greater than critical angle of the pair of medium, then that is completely reflected back into the same medium, and this phenomena is called total internal reflection. So please write, when light ray goes from denser to rarer medium, when light ray goes from denser to rarer medium, such that angle of incidence is greater than critical angle, such that angle of incidence is greater than critical angle for the pair of media for the pair of media, the light ray is reflected back completely into the same medium. The light ray is completely reflected back into the denser medium. इसमें कोई पॉलिश नहीं की थी हमने, फिर भी हमें ये लाइट पूरी की पूरी वापस आ जाएगी उसी मीडियम में, and therefore it is called total internal reflection. Light ray is completely reflected into the same denser medium. Hence called as total internal reflection. When you write the definition of TIR, you have to write both conditions. Light should go from denser to rarer, and the light should be incident at an angle greater than critical angle. अगर एंगल क्रिटिकल एंगल से बड़ा है और लाइट रेरर से रेरर में जा रही है, only then it is possible to have TIR. If light is going from denser to rarer, there is no chance of TIR. Total internal reflection को हम short form में TIR बोलते हैं. Total internal reflection takes place only when the light is going from denser to rarer and the angle of incidence is greater than critical angle for that pair of media. Correct. अब जो critical angle है किस पे depend करता है, on what the critical angle will depend, the factors affecting the critical angle. Yes, critical angle किस पे depend कर रहा है from this formula? From the formula of critical angle, on what factor it depends? Mu.
Refractive index.
And refractive index depends upon what?
Wavelength.
Wavelength, right? It depends upon wavelength. It depends upon the optical density. Optical density, like for the air or the air-like packets, it is dependent on temperature as well. Like the temperature increases during the daytime. During the daytime, the density of air layer is different as compared to the density in the night. In the night, they are denser. In the daytime, they are relatively rarer medium. So refractive index, sorry, this angle of critical angle depends upon these two factors: wavelength and temperature of the medium. It depends upon wavelength. Wavelength पे change करने पे refractive index change होता है, refractive index change करने पे refractive index change करने पे angle of contact will change. I'll just convert sometime. So less lambda means greater mu. Greater mu means less critical angle. So least wavelength के लिए least angle of contact होगा. Like for the violet color, it will be least. Violet color के लिए refractive index सबसे ज़्यादा, तो critical angle सबसे कम. So it will be least for violet color. Right? Critical angle will be least for violet color. Second, it depends upon temperature of the medium. The density of medium changes with the temperature, like the gas and the air. Hot air will be rarer medium and cold air is relatively denser. By changing the density, mu changes, so critical angle will change. What are the two essential conditions for TIR to take place? Tejasvi, total internal reflection के लिए कौन सी दो basic condition है, necessary condition है? Tejasvi, What are the two necessary conditions for total internal reflection? Yes. दो condition कौन सी हैं, Mr. विक्रमादित्य? What are the two conditions under which we will obtain the TIR? Light कहाँ से कहाँ जानी चाहिए? Denser से rarer. Light should go from denser to rarer, and the angle of incidence should be greater than critical angle.
Sir, can you please repeat what you just said?
The essential or necessary condition for TIR to take place, total internal reflection के लिए दो necessary condition क्या है? That light should be going from denser medium to rarer medium, and the angle of incidence should be greater than angle of critical angle for that pair. पहला है light should be going from denser to rarer medium. Second, the angle of incidence has to be strictly greater than, not just equal to. इनको आप words में लिख लोगे. The angle of contact, angle of incidence should be greater than critical angle for that pair. ये दो necessary condition है. अब जब total internal reflection होता है तो हम ऐसा assume कर सकते हैं कि 100% light is reflected back.
सर मुझे ये सेकंड
जब-
वाला पॉइंट समझ नहीं आया कि एंगल ऑफ इंसिडेंस शुड बी ग्रेटर देन क्रिटिकल एंगल.
फिर से समझो, ये डायग्राम इसलिए बनाया था मैंने. ऑब्जेक्ट यहाँ पर है, जब एंगल ऑफ कांटेक्ट, एंगल ऑफ इंसिडेंस छोटा होगा तो लाइट बाहर आ रही है. दिस इज रिफ्लेक्शन, नॉर्मल रिफ्लेक्शन. When angle of incidence is less than critical angle, the light will go strike on the boundary and emerges on the other side.
यस सर.
And when light is incident exactly at angle of critical angle, जब ये बहुत छोटे एंगल पर होगी तो बाहर निकल आएगी. When it is at an angle of exactly equal to angle of critical angle, then light will emerge exactly parallel to the surface. ये IC और ये 90. Third, when light is incident at an angle greater than critical angle, then only it will be reflected back. पहले वाले में तो दूसरे मीडियम में बाहर चली गई, सेकंड वाले में parallel, और थर्ड वाले में it is coming back. जो TIR की कंडीशन है कि उसी मीडियम में लाइट वापस आ जाती है, वो तभी होगी जब एंगल ऑफ इंसिडेंस इज ग्रेटर देन क्रिटिकल एंगल.
समझ गया सर.
रेयर से डेंसर में अगर कोई लाइट रे जाती है, then it is not possible to have total internal reflection. Light will suffer total internal reflection only and only when it is incident from denser to rarer at an angle greater than critical angle for that pair of medium. अब इसमें एक जो दूसरी सिंपल कंडीशन यहाँ पर हम यूज करते हैं, जब हम मिरर बनाते हैं, मिरर में क्या करते हैं, वी पॉलिश वन सरफेस, और पॉलिशिंग में एब्जॉर्ब सम ऑफ द लाइट. सो इट इज नॉट नेसेसरी दैट फ्रॉम अ मिरर the incident light intensity or brightness will be equal to reflected light ray. This is not necessarily true because that painting or that polishing, that coating will also absorb some amount of energy. Reflection में 100% light reflection नहीं होती. Some amount of light will be always absorbed by this polish or by the medium. Done?
तो सर लेकिन वो हम लोग मल्टीपल इमेज फॉर्म वाया थिक मिरर, उसमें तो हमने ऐसा करा था
तो
कि
सबकी इंटेंसिटी कम होती जाती है ना.
हाँ, तो रिफ्लेक्शन
क्योंकि लाइट हर
लेकिन
बार absorb होती है.
पॉलिश सरफेस में लेके ना, जैसे अगर
पॉलिश सरफेस
90%
मैक्सिमम होगी, but it will not be 100%. In reflection from plane mirror, it is maximum, but some amount of light, though it will be very small, in the reflection from plane mirror, some amount of light is always absorbed. Some amount of light is absorbed by the polish, by the or the medium, hence 100% light is not reflected back. Hence 100% light is not reflected. ऐसा हम अभी assume कर लेते थे, but that will not be a practical case, क्योंकि जो भी हमने coating लगाई है usually mercurous sulfide or lead sulfide, that will have some amount of light absorbed. But in the case of total internal reflection, it is not because of the absorption, it is a natural phenomena. In the process of total internal reflection, 100% light is reflected back. In the process of total internal reflection, the light is 100% reflected back. No energy is absorbed or no intensity is absorbed by the surface. इसीलिए इसका नाम है total internal reflection. And because of this phenomena only, it is used in many optical devices like binocular, periscope, camera. When we have to do the reflection, we don't use the normal plane mirror. Instead, we use a prism causing a total internal reflection. Again, अगर हमें लाइट को रिफ्लेक्ट करना है किसी भी सरफेस से, एक तो तरीका है वहां पे नॉर्मल प्लेन मिरर रख दे, but we don't use that plane mirror normally. What we do is, instead of the normal plane mirror, we put a prism which causes the total internal reflection of light, like in the case of binocular, periscope and camera, the total internal reflection is used. और वो कैसे होता है प्रिज्म में, that we will just see. Next concept is total internal reflection is prism. पहले यहाँ तक any doubt, please you can ask. पहले वाले में रिफ्लेक्शन हो रहा था किसी बाउंड्री से. Second scenario is it is the reflection from a boundary separating denser to rarer medium. Correct? In this case, it is not a polished surface. Even the 100% light will be reflected back. 100% intensity is reflected back. Got it?
Yes, sir.
एक बार देख लो पूरा कॉन्सेप्ट, इसमें कोई डाउट हो. There are many practical application of this TIR phenomena also. Many practical application, and obviously it is used in many optical devices to reflect the light, because if you use a normal plane mirror, that reflects the light, but on the cost of intensity is slightly reduced. When intensity is reduced in a plane mirror, though it will be a very less, maybe 2%, 3% only will be absorbed, but it will be less. In the case of TIR, there is no absorption of intensity at all. चलो ठीक है, आगे बढ़ते हैं हम। रिफ्लेक्शन फ्रॉम प्रिज्म।
Sir, reflection from plane mirror and total internal reflection का difference आ सकता
बेटा यहाँ पे समझने वाली बात ये है कि हम जब मिरर रखेंगे तो मिरर में कुछ कोटिंग होती है पीछे, some polishing is there due to which it is reflecting back. Now that coating will also absorb some amount of light. So हमने जितनी लाइट उस सरफेस पे मिरर पे इंसिडेंट की है, the same amount of light will not come back. Some amount of light is always absorbed by that surface, by that polishing. Therefore 100% intensity will not come back. बट जब हम TIR की बात करें, टोटल इंटरनल रिफ्लेक्शन इज नॉट बाय द एब्जॉर्प्शन। इन दिस केस जितनी भी लाइट आई थी, यानी जितनी ब्राइट ऑब्जेक्ट था उतनी ही ब्राइट उसकी इमेज भी बनेगी। द इंटेंसिटी ऑफ लाइट रिफ्लेक्टेड इज 100% exactly same. There is no absorption take place in the TIR phenomena.
Sir, is total internal reflection a real thing, or is it like an ideal machine where it's simply
No, no, it's a real thing. It's a real thing. Absolutely real thing. When you go on the highway during summers, you see water or you see some liquid on the surface. It's like there is oil spilled everywhere. That is because of total internal reflection. You see from the any water body, maybe lake or pond, if you are seeing at some angle, you see your own face instead of the object present inside. अगर हमें फिश देखनी है तो हमें परपेंडिकुलर जाना पड़ेगा। अगर हम साइड से किसी एंगल पर देखते हैं तो हमें अपनी शक्ल दिखती है, बिकॉज इट स्टार्ट बिहेविंग लाइक अ प्लेन मिरर बिकॉज ऑफ द रिफ्लेक्शन। Another application, practical application is diamond. Diamond has a glow or diamond has a brilliance because of light is getting multiply total internal reflection inside the diamond. Another, the formation of rainbow is again due to total internal reflection. These practical situations we will discuss in the next class. अभी हम बस ओरली एक बार बात कर लेते हैं. What exactly is the TIR? So there is a phenomena of mirage. What is the mirage? In the hot surfaces or in desert, there is a illusion of water on the surface. Though there is no water, when you go there, it seems that there is water, but there is no water. Again, water appears quite far from that point. So that illusion of water on the surface is again caused by mirage. Suna na mirage? Heard of this word?
Yes, sir.
Mirage is another word for illusion, by the way. So similarly, in the cold desert means like Arctic, Antarctica, and the Arctic Ocean. There is an opposite phenomena. It's called looming. We will discuss class. वहाँ पे ship surface से थोड़ा ऊपर float होते हुए दिखाई पड़ती है हवा में. In the cold desert, ship and all the other object appears to be floating above the actual surface. So all these illusions or all these phenomena are because of mirage. ठीक है? Right? So इतना revise कर लेना इसको और we will do this tomorrow. Okay. Tomorrow probably I'll take class at 11. I'll discuss with the Abhijit sir if it is possible. I'll take class at 11 afternoon. I have to go to office. Right, so yes, tomorrow probably class will be at 11. The first class, I'll switch with Abhijit sir. Okay, revise this and we'll continue tomorrow then.
Thank you,
Thank
sir.
you.
Bye.
Thank you, sir.
Thank you, sir. Bye.
Bye bye.